Hey everybody, this is Larry. This is day 19th of the May Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Minimum moves to equal array elements to. So I usually solve these live, so it's a little bit slow. Feel free to fast forward, watch on 2x, whatever you need to do. Okay, so let's actually read the problem. And if you're a watcher of my stream, you'll know that I've been doing really poorly of that lately, and I keep making silly mistakes on the reading, so I keep on solving multiple problems. But anyway, so let's actually read it this time. Okay, you have a length n minimum, or you can one move, you could increment or decrement an element of the array by 1. Okay. I mean, I think this is, there may be a couple of ways to do it, but let me think. So the first observation that you should make is that if all elements are equal, it always makes sense to pick one of the numbers. And this is actually just something that I was going to say that it's obvious, but it's really not. It's just something that you do from experience. This is related to, if you think about, there are other problems that are similar but not quite the same, where you have goalposts on an integer thing, and and you have to figure out where to put like the whatever, and the answer is usually the median. In this case, it's not the median as in the perfect median, but it is probably just one of the two numbers in the middle. Is that even true? No, well, it's not. No. Because you can, in this case, there are duplicate numbers. Actually, I won't give you one as an example, but it still would be one of the numbers because there are only a couple of scenarios, right? So without loss of generality, you can kind of reduce it to, let's say, well, I'm just going to give an example, but it's not a hard proof per se. But for example, if you have two goalposts and one of them is weighted more than the other, then there are only a couple of scenarios, right? Do you ever want to be in the middle of two goalposts? The answer is probably no, right? Because either it is the same. I don't think I'm going to say this correctly, but try to kind of, I will give you kind of maybe a way to visualize this. But let's say you have to decide between two points, and it doesn't have to be the 2 points in the middle, or just be any 2 points. Let's say you're trying to decide between 2 points, then the answer is either one of the 2 points, because if you choose the middle, then if it is exactly in the middle, that means that you could choose either one of the 2 points with and it doesn't matter, right? Because there's equal number to the left and to the right of the 2 points. So that means that if you could choose the number in the middle, let's say you have, I don't know, 4 and 10, and the number in the middle is 6, right? 8, 7? Can't do math today, right? But but in the same way, let's say there are 3 numbers to the left of 4 and 3 numbers to the left of I don't know how to represent this, and 3 numbers to the right of 10, and then in that way, 7 is going. If 7 is the possible answer, the same answer you're going to get with 4, and the same answer with 10. This is because everything is an integer. And if there's more on one side, then you just move it to that side anyway. You want it to be 10. So in that case, then the answer is always going to be one of the numbers, and then. Okay, and then there are probably 2 ways of doing it. After I, all that said, I know I spent a lot of time trying to figure out how to explain that part. But yeah, but once you make that observation, then there are only 2 ways of doing it. One is sliding window, and then the other is maybe some sort of math on a frequency table. But even then, that may be a sliding window anyway. So yeah, so what I'm going to do is, let's just do sliding window. Let's just sort the nums, and then we'll just do the math as we go from left to right. It's not a sliding window, sorry. I say sliding window, but I mean It's just a sliding something. Frontiering. I don't know the term for it, but basically you have like a scan line algorithm. Maybe that's a better way of it. You're scanning from left to right, and as you change from point to point, you calculate the minimum number. Oh wait, did I mess this up? Oh no, okay. Because there is I forgot whether there's a variation. I was so worried that I misread this again, because there are variations where it's just you can only increment or you can only decrement, and obviously they have different answers. But I read it correctly this time. Okay. Seems I don't know if this is. But anyway, so yeah. So then now we just have to calculate it for one point, and then we just kind of do the math on each one, and we'll do the math together. I probably helps to do it on the fly, but yeah. But let's say left side is equal to 0. Left side is equal to 0. Right is equal to sum of nums, maybe sum of okay. Right, so that basically wait, is it sum of nums or count of nums? No, this is fine. Basically, this is saying oh, actually, maybe that's a little bit different, because there could be negative numbers, but that's fine. We could just reindex everything. So yeah, we can just reindex, and then mathematically it doesn't make a difference, but it's just easier to visualize for me, and also that that what I'm going to say, this will make it true, which is that to the left we have 0, the sum of all the numbers are 0, and then to the right all the sum of all the numbers are this, right? And that makes it so that the sum of the numbers are that. So now our current point, our current scan line is at point 0, and then everything. So the sum of all the nums is just the sum of all the distances to make it 0. Right? Okay. So we take the min, and then we just subtract everything from min. Is it subtract from min? Yep. And again, this doesn't change anything, but it just makes it easier to do, for me to visualize in case there's something wrong. Yeah. Yeah, so now we go from 0 to the first index. So let's see, right? So nums of index is the current index. So delta is equal to the previous. So actually, yeah, let's just say previous is equal to 0. Is it this minus previous? Yep, this minus previous. So this is the delta that you're moving. I think I need to keep track of count as well. Left count is equal to 0. Right count is equal to n, right? And then I guess that's actually just part of index. That's why I didn't do it the first time. Okay, fine. Right now we move to the first point. The left count is equal to index, because and then right count is equal to n minus index minus 1, maybe. Because if we get the first point to the right, there's n minus index minus 1. Okay. And of course this increment and decrement, which we could have done, but I just keep everything in a tighter way. It doesn't really matter. A couple of operations, but yeah. So then now left we minus this delta, or we add this delta, because we moved everything to the left. Well, I think this is the way to do it. So the left we added by the delta times the number of elements on the left. Okay, I wrote index, but I meant this, which is the same obviously in this case. And then on the right we minus this delta, right? Basically it's just everything shifting over to 1. Yeah. And then now the total number of moves is just equal to left plus right. and then best is equal to the min of best total, and then we return best, and total we set, or best we start at some infinity value. I always just choose this, just our custom, I don't know. Let's also put in this one. I think that's roughly maybe right, but maybe I'm off by one on the, I have some doubts about yeah, so we're off by one. Why? Tell me why. Let's print it out real quick. Should have used f string, but yeah. So okay, to the right this, yeah, maybe I should use f string. Let me retype this. Always forget about f strings. And this is very new. If you're using Python for a long time, if you are not up to date, this is actually pretty cool. So definitely recommend doing that. It's just a little bit more typing, and I'm a little bit lazy, but this has too many parameters, and as you can see, it actually is pretty cool. Okay, so to the left, when we're here, maybe I did the math wrong, but the idea is still right. It's just my math is really, I don't know, it's really tired. I didn't sleep enough the last couple of days. But yeah, so that's my excuse. I'm sticking to it. So the sum of left is the right total is wrong. Oh wait, no, because I re-indexed everything to 0. So that's right. And then we go to the first place. Delta should be 0. So the number of moves would be 3. That sounds okay. So this is okay so far. And then now I move one to the right. So I go from the 1 to the 2. To the left, we have one move, we have one count. Okay, that's right. To the right, we have one move. Oh, we have one count, but the right is, yeah, I think I knew that, or I didn't knew it, but I was did have some weirdness about it where the right, oh no, this is just off by 1. N minus index minus 1. This should be right? To the right. No, because you're on the, okay, so it's -1 minus 1. Would that mess me up later? Oh no. Well, I mean, this clearly did not go right though. The right count, did I mess that up? Right, oh no, I was looking at the wrong column. Okay. Now this should be right for the right count. Okay. And then now there's 1 to the right, but so the delta is 1. Oh, but the shift is so that, okay. So this should be this plus 1. Yeah, because that's the number. I count the numbers to the right, but not including that number, but this number also shifted. So this should be good. Okay. So yeah, so I just have an off by 1 because I wasn't clear about what my understanding, but should be okay. Let's actually, I was going to say, what's a good test case to run? Let's try negative numbers, for example, but this is just a random case, and ooh, well, this is just wrong then, right? Is it wrong on the duplicate numbers, or? So I think I handled the duplicate numbers a little bit awkwardly. Okay, so not that, at least not only that. Why is this wrong then? So it's wrong even just having more numbers. That's awkward. Okay. Let's do this print statement again then. Oops. Let's actually look at a smaller example maybe. I hope that gives me the wrong answer so that it's easier to debug. No, that gives me the right answer. So why is this giving me the wrong answer? And the thing about knowing how your answer is wrong is interesting as well, because if this is lower than the best answer, that means that you have gone something wrong. Where if your answer is higher than your number, it could be an implementation detail, but it could also just be like if you're doing greedy, your greedy is not correct enough. But you know, if you're like greedy might not be the right solution. But in this case, this is just off. Lucky I test, I suppose. Let's see, to the right is 117, that's 4 numbers. Let's see, yeah, because there's these 4. I said, well, this is kind of awkward in general. Because to the right, this should never be negative. So I think I'm just off by something here. Probably used by this off by 1. Okay. I mean, I think to be honest, I was just lazy about doing the math. Because okay, I know why this is wrong. I think I was just hand wavy a little bit. Because basically, there are actually 3 different things that are moving. It's just that I for some reason I wasn't thinking about it. Or I was trying to be lazy. So there are actually 3 states happening. And I only accounted for 2 of those, which is that when you shift from, let's say you have a line and you shift from here to here. Oops. Let's say you have 3 numbers and you shift from the left one to the right one. So this is the delta. Then you have the right count plus 1 sum, we subtracted from here. And the left count, no, I mean, that seems right. That's why I thought there was another one where one number gets zeroed out because you move it to there, but it should be factored in, right? What am I doing wrong? Dong, dong, dong. We don't want to do this by hand, so let's see. 117. I assume this is right because this is just a sum. Let's just also add a 0 in there so that I don't have to worry about. Because the reason why is because we re-indexed everything, so that would make the things inconsistent. So yes, the sum is 122, which just by looking at it, that makes sense. So that's 22. This is 22, 122. Okay, and then we move to 1. We move to 1, and then now to the left is 1, and then to the right there's. Actually, we can do something dumber, right? We're gonna do right audit is equal to sum of. Don't do what your computer can do for you, right? What's it? N minus index minus 1, or just index, I guess. The suffix of now it's just plus 1, and the left audit index, right? Okay. And then now we can just look at the left-right audit that much. This is not right either. This is what we want is actually the sum of all the numbers minus this number. So my audit, this is not quite right. This is let's see. Sum of x for x in this minus numbers of index. That's what I mean. Yeah, okay. And that's basically what I guess I should have mentioned this earlier. But that's basically the what we want to do, but we do it in a sweep line kind of way. So if you were and maybe I got the signs wrong, but that's fine because we can look. Yeah. But the idea here is that you're basically calculating these sums, and then you're moving it from left to right and calculating the delta. Maybe I should have done it the mathematical way more versus the visualization way. But yeah. But you can kind of see that the left audit is not equal to the right audit, even in the first case. Actually, is that true? I just didn't do the math. Yeah, left count is really off. So that's left sum is really off because that's 1 plus 2, and this is 5 for some reason. So every number, the delta should be right though, right? Why is this wrong? So when we're here, there's 1 to the left, 1 to the right, and then when we get to the right, then that means that 2 numbers add 1. No, that doesn't make sense, right? When we get from 1 to 2, index 1 to index 2, then the 2 numbers to the left that needed added 1, so that's added 2. So what do I put here? So there's 2 plus times delta, right? Oh, I didn't update previous. Is that why? I was okay. Well, okay. I usually write it a different way, but I guess today I wrote it a different way. And what I mean by that, I usually write something like obviously just this. But then I this time I didn't do it that way because I wanted to change the index. I didn't want to change the index. And then instead I did all this other stuff thinking that, okay, remember Larry. And I remember telling myself this in my head. I'm like, remember Larry, don't forget to update the previous. And then I forgot to update the previous. Okay. So silly implementation mistake. Thank you for following along if you're still here, but as you can see, silly mistakes happen. You can tell me in the comments how long I spent on this because I'm not going back quite yet. But yeah, now let's try more numbers then. And as we said, let's try some negative numbers. The way that we implemented it shouldn't matter. If this looks good, then I'm more confident. Okay, so this looks good. I'm confident. Let's give it a submit. If you're in another language, I would also double check the data types to see if it overflows and stuff like that. But I'm in Python, so I don't think about it actively, which sometimes bites me. But yeah, okay, so this looks good. Let's go over the complexity. The most of the complexity is just sorting. I mean, in space complexity, we can actually do this in all of one. You can probably, see how it's just that the way that I did it, because I re-indexed everything and create a new array. It is going to be O of n, but you can do it without it. I don't even think this is really necessary, to be honest. I think this actually works. No, I think now you have to do this, but maybe that should still work. But I just wanted to make debugging easier in case I've debugged with negative numbers, so I was wrong on that. I think because this is wrong, and we have to do another loop, but that's fine. Because the sum that is now wrong because we you just have to do the math on that. But anyway, so this is going to be linear time because we just n log n time because we sort, but after that we just go through the array, and linear space because we create in a serial array, but you can trivially convert this to constant space. That's that's all I have. Apologies for debugging silly mistakes for so long. But I am doing these at 3 a.m. I don't know why I'm doing these at 3 a.m. So, this is not 100% of me, I think. But anyway, still hope it helped. Hope you enjoyed this problem. And yeah, I think this one, if you ask me, in theory, it's not that bad. But in actuality, there's a lot of observations that will, if you have practiced similar or other problems, that you could draw parallels from, will allow you to answer it much, much, much quicker. I haven't seen this particular one per se, but as I said, I like the way that I thought about it was about the problems of the goalpost or signpost or post office or whatever it is. So yeah. And this thing comes in handy, and you can kind of think about these as just, this sum and this sum, except for now you're changing it, one sum at a time, and then trying to figure out the delta and then do the math on the delta. I probably hand waved this a little bit too much in that I did in my head, so I didn't show the work, but definitely work it out and make sure you understand it. It's actually kind of nice. You just write out the formula and then kind of, subtract to adjacent answers as you do in math. But yeah, that's all I have for this one. I'm a little bit tired, so otherwise I might go in detail in that particular case. But yeah, stay good, stay healthy. I will see you later. To good mental health. Bye bye.